All right, here's example 4 with trig identities. So again, if you want to copy this worksheet we're using here, check the video description. You can click that link and open this up, print it out. Okay, so sine of u times the cosecant of u minus the cosine squared of u equals sine squared of u. Okay, so we'll go back to our general process here. So again, always start on just one side, try to make it look like the other side, so don't manipulate both sides at once. Okay, so just mess around with one side only. And usually start with the side containing the more complicated expression. The left side is definitely more complicated. So on the right we're squaring something, but here we're multiplying two things, subtracting and squaring. So it's a little more complicated on the left. So let's try starting over there. Okay. So what do we have? Sine, cosecant, and a cosine squared and a sine squared. Okay, so if we think, okay, what does this kind of look like here? Well, nothing really jumps out, but we do see a cosine squared and a sine squared. So if we look at the Pythagorean identities, we also see a sine squared and a cosine squared here. So maybe that's going to be somehow involved. We're not really sure yet, but maybe. Okay. Now, you actually, looking at that, you might be tempted to say, well, hey, let's add cosine squared to both sides. But remember, we can't do that, right? Because we can only mess around with one side. Okay, and we decided that since the left side is more complicated, we're going to try and start there. So let's do that. Okay, so again, do not add cosine squared to both sides because you don't want to mess around with both sides. Okay, you only do that if you're solving an equation, and we're not solving an equation, we're establishing an identity. Okay, so an equation is something that's, generally speaking anyway, it's only true for a few values of the variable. Okay, so when you solve an equation, you're trying to find the values of the variable that make it true, make the equation true. But here, this is an identity. Okay, this is true no matter what the value of u is, as long as the cosecant is not undefined, right? But we don't worry about stuff like that for identities. Okay, but anyway, the point is we're not solving an equation, so we're not going to treat it like that. Okay, we're establishing an identity, and there's a different way to treat things like that. So for solving an equation, you manipulate both sides, but this is not solving an equation, so we're not going to do it like that. Okay, sine of u times cosecant of u minus cosine squared of u. Okay, so what's that going to equal? So, okay, so here we have a sine, here's a cosine squared. Well, let's look at this here. Sine, cosecant, cosine squared, and a sine squared. So this is all sines and cosines except for the cosecant. So let's maybe, so one of our steps in the process here is to rewrite expressions in terms of sines and cosines. So again, this won't always work. Okay, it might not always work, but let's just try that. So sine of u, that's already sine, and then cosecant is 1 over sine. Okay, and then we have minus cosine squared still. Okay, so what's happening now? Well, sine of u and sine of u cancel, we're left with the 1, that's good. So what we have is 1 minus cosine squared of u. Okay, so how does that help us? Well, now let's go back and look at this Pythagorean identity here. Okay, so let's look at this. Sine squared plus cosine squared of theta, that's 1. Okay, so let's come off to the side here. Okay, we're going to come off to the side here. So sine squared of theta plus cosine squared of theta is 1. Okay, well, we can actually rewrite this and we can say, okay, that's the same thing as 1 minus, so if we subtract cosine squared from both sides here, that's the same thing as saying this. Okay, so sine squared plus cosine squared of theta is 1, that's the exact same thing as saying this, 1 minus cosine squared of theta is sine squared of theta. Okay, so now here's a theta, this here it's a u, but that does not matter at all. Okay, so whether it's theta or u, it's the exact same thing. Okay, so 1 minus cosine squared of theta is sine squared of theta, or 1 minus cosine squared of u is sine squared of u, whether it's theta or u or x or t or v or w, whatever. So 1 minus cosine squared of u is sine squared of u, okay? And that's what we wanted, right? That's the right-hand side, so we've just shown that the left-hand side up here equals the right-hand side, okay? Now, in case you're wondering, hey, didn't you say that we can't subtract things or we can't do some things to both sides? Yes, but only here for the thing that we're working with, okay? So what we did here was we took an established identity, okay, one that's already been established, and we manipulated it to use to our advantage, okay? So here, we're not trying to establish this identity, right? This is one that's already been established, we already know it's true, so we can use that in any form that's useful to us. That's why for this, it's okay to subtract cosine squared from both sides to make it, you know, in a more useful form. Okay, so here we just subtracted cosine squared from both sides, and then I swapped the sides for some reason. Okay, that's okay to do that here because it's an established identity and it's okay to manipulate those to use to our advantage. But here, we don't know, you know, we're in the process of establishing this. So when we're establishing an identity, we can only work on one side, okay? But if we're using an identity that's already been established, we can manipulate it as long as it's a legal manipulation. Okay, you know, like subtract the same thing for both sides. That's an okay thing to do. So as long as we do something like that, then it's okay to use that. Okay. So again, for an established identity, you can manipulate it to use to your advantage. But for an identity that you're trying to establish, like this one here, only work on one side. Okay, just work on one side, try and manipulate just that side to make it look like the other. Okay, so that's the difference. Is here we're establishing this identity, but here we're using this previously established identity to help us. So that's why it's okay to do this here, but again, never ever do that here for an identity that you're trying to establish. Okay, so just to recap what we do, we rewrote in terms of sine and cosine, canceled those, we ended up with 1 over here, so that we had 1 minus cosine squared of u, and then we used the Pythagorean identity in a form that's more useful to us. So that's really all we did. So here's the Pythagorean identity here, and again, we use that in a form that's more useful than just that. Okay, so, and there are other ways we could have thought about that. You know, we could have said, okay, well, 1 is the same thing as sine squared plus cosine squared, so let me replace the 1 with sine squared plus cosine squared, and then I'll simplify that and I'll end up with sine squared. That's, it's kind of goofy, but it's totally doable. You can totally do it like that. Absolutely nothing wrong with that. Not a bad idea really, it's just a little bit different, but it's really, there's nothing wrong with that at all. Okay, so again, we could just take the 1 and say, hey, 1, that's the exact same thing as sine squared plus cosine squared, so let me substitute that into there and simplify and so on. And you'll still end up with the same thing. Okay, so a couple different ways to think about it. Anyway, that's example 4 with trig identities. Example 5 coming up next.